All right, here we go. So here is our warm-up and all I'm asking you to do is solve the following radical expressions. So when we do that, whenever you have the square root of 2x plus 5 equals 7, you're going to notice that you can go ahead and, bear with me, this is the first time I'm doing this. So we're going to end up having 2x plus 5 inside, and then we're going to square. I'm going to clean this all up. Let's try this again. So we're going to square both of those. Okay. So both of those would be squared. So we're going to end up with 2x plus 5 equals 49. Okay. Now we're going to subtract 5 to both sides. We're going to end up with 2x. This simplifies. We're left with 44. And then divide both sides by 2. And then we have, this simplifies to 1. We're left with x equals 22. But we do need to double check. So we're going to substitute it back into the equation, and we're going to end up with the square root of 2 times 22 plus 5, all inside the radical, equals 7. 22 times 2 times 22 is 44, plus 5 equals 7, all still in the radical. This simplifies down to 49 equals 7. Square root of 49 just becomes 7. 7 equals 7. So we know for a fact that the number 22 does work. So 22 is a solution. So we can go ahead and move on. All right, so with number 2, I'm going to go ahead and change the color here. So we're going to go ahead and start off with 2 square root x minus 4 equals 8. Now notice how on this one we have the negative 4 going on. So what we're going to do first is we're going to go ahead and add the 4 to both sides. When we add 4 to both sides, we are left with 2 square root x equals 12. Next step is we're going to go ahead and divide that coefficient 2 out. So we're going to end up with the square root of x equals 6. And next, because the inverse operation of a square root is to square both sides, well, that's what we're going to do. We're going to square both sides. We're going to be left with x equals 36. Okay, we do need to test it, so we're going to go ahead and substitute it back in. So that's going to be 2 times the square root of 36 minus 4 equals 8. So this is us checking it. Okay, square root of 36 is just 6. So we're left with 2 times 6 minus 4 equals 8. I'm going to go ahead and try to get some more space down here. All right, that's just going to be 12 minus 4 equals 8. 12 minus 4 is going to give us 8 equals 8. When you are checking it, make sure you simplify this left side without moving anything left and right. Okay, so 8 equals 8. We do know that x equals 36 is our solution, and we're good to go. Okay, so today's notes, we're really looking at solving radical equations part 1. So a radical equation is an equation in which a variable appears under the radical sign. So always remember we need to isolate the square root and then square the square roots. All right, here's our third example. So with this one, we're going to go ahead and isolate the radical first by subtracting 7 to both sides. And then we're left with 1/2 times the square root of x plus 2 equals negative 4. Now we multiply both sides by 2 to get rid of the 1/2, because if we multiply by the reciprocal, which would just be 2, that would simplify out. We would just be left with x plus 2 equals negative 8. Now, if we want to get rid of the square root x plus 2, we would just square both sides. Okay, so that's just going to end up being x plus 2 equals negative 8 squared is going to give you positive 64. Let's subtract 2 to both sides. We're left with x equals 62. And that's our solution. Now, we do have to double check our problem here. We're going to substitute it back in there to the radical, so we're left with 1/2 square root 62 plus 2 plus 7 equals 3. Now, one step at a time, we're going to go ahead and take 62 plus 2. That's going to give us 64. The square root of 64 is just 8. And half of 8, or if we take half times 8, that's just going to give us 4 plus 7 equals 3. So if we add those together, we would end up with 11 equals 3. Now, 11 does not equal 3, and if it does not equal 3, then x cannot be 62. And what's really happening with this graph is this entire graph is being, when we graph it, if we were to look at the parameter changes, that plus 7 is going to tell us that it's going to shift up 7 on the y-axis. So it's going to go 1, 2, 3, 4, 5, 6, 7. That 2 is going to tell us that it's going to shift right. I'm sorry, left 2, 1, 2. So when we graph it, it's going to graph like this, and we have a 1/2, so it's going to go something like that. Okay. And it's asking when it's going to end up being 3. So when does that equal 3? It doesn't equal 3 though, because the y value for 3 is right here, and it's never going to cross. So there is no solution for this problem. No solution. All right, so let's go ahead and take a look at number 4. Number 4 starts off with the cube root of x minus 3 plus 2. So what we're going to do now is we're going to go ahead and isolate that cubic. We're going to subtract 2 to both sides. All right, so we end up with the cubic the cube root of x minus 3 equals 1. Now, in order to get rid of a cube root, the inverse operation is to go ahead and cube both sides. So that's just going to end up being 1 cube equals x minus 3. The cubes and the cube root simplify out, and we're left with x minus 3. We're going to add 3 to both sides. 1 cubed is just 1 times 1 times 1, which is just going to become 3. So, which is just going to become 1. So we really no longer have that 1 cubed anymore. Okay, so in this case, we're going to be left with x equals 4, but we can't, with cubic equations on the graph, what's truly happening with this is a cubic equation. If I were to look at y equals x cubed, that's what that would look like as a cubic equation. But if I'm looking at the inverse operation, that's going to reflect over y equals x. Okay, so this is y equals x. If it reflects, that's going to go shift down. Okay, so this part is now going, this part in the first quadrant is going to reflect, and it's going to reflect like this. And that's going to be the inverse function, which would be the third root of x. All right. So, with that being said, as far as how it's graphed, there are no domain restrictions, so we're not going to have a part that is a no solution. You can always substitute it back in, though, to double check to see if your math is correct, so do check that. Okay, so we're going to substitute it in just to see if our math is correct. Plus 2 equals 3. So 3 minus 4, that's just going to give us 1, so the cube root of 1 is really 1. I'm going to scroll this down. 1 plus 2 gives us 3. So I know for a fact 3 equals 3. We do know that x equals 4 is our solution. Okay, so let's go ahead and take a look at another example. We're going to get into some complicated examples when we have radicals on both sides. I just want you to take a second to think about what you would do in this situation. Okay, if the inverse operation of a radical is to square both sides, that's what we're going to do here, and we're just going to go ahead and square both sides. So when we square a radical, the square and the radical simplify, and we're left with 8x minus 14 equals 6x plus 10. Okay, now just solve it like you would any algebraic problem. I like to move the smaller coefficients over so I end up with a positive coefficient in the end. Okay, and I'm going to add 14 to both sides. Okay, this simplifies, I'm left with 10 plus 14, which is 24. Divide both sides by 2, x equals 12. All right, now we are working with radicals, so we need to substitute it back in to see if we do have a solution rather than having just an extraneous solution. It's hard to write with this stylus. Okay, so we're going to end up having the square root of 8 times 12 minus 14 equals 6 times 12 plus 10. Okay, I'm going to go run and get my calculator real quick. All right, 8 times 12 is 96 minus 14 is going to give us the square root of 82. Now on the other side, 6 times 12 is going to give us 72 plus 10. That's going to also simplify down to 82. So the square root of 82 does equal the square root of 82. That means my x equals 12 is our solution. Okay, so let's go ahead and take a look at another complicated problem. Now this one's complicated because we have this coefficient 3 in front of a radical x, the square root of x. So what we're going to do is, in order to get rid of that, we're going to go ahead and square both sides. Now, I want you to think about this 3 square root x as being 3 square root x times 3 square root x, because when we square it, we have 2 of them, so that's just going to end up being 9. Okay, and then x times x is x squared. The radical simplifies, and we're left with just 9x. So this is going to simplify down just to 9x, and then over here, the square and the radical simplify. So we're left with 2x plus 14. Okay, so I'm going to go ahead and clear this out over here. Whoa, what did I do? Okay, clear this out. Yay. And then we're going to go ahead and simplify the rest of our equation over here now that it's turned into a regular algebra problem. So we're going to subtract 2x from both sides. That's just going to give us 7x equals 14. Divide both sides by 7. We're left with 2 equals x. Let's double check, substitute it back in. So we have the square root of 2 times 2 plus 14, all under the radical, equals 3 square root 2. 2 times 2 gives us 4. 4 plus 14 is going to give us 18. Square root of 18 equals 3 square root 2. Be careful. Sometimes students will get to this point and they're like, square root of 18 doesn't equals 3 times the square root of 2. But you need to break down 18 and see what that really multiplies out to. So 18 is actually 3 times 6 and 2 times 3. So we end up with 2 groups of 3 with a remainder of 2 on the inside. Okay, so 3 square root 2 does equal 3 square root 2. Square root of, 2 equals y is our solution, and we're good to go. Let's go ahead and take a look at number 8. Now, number 8 starts off with a coefficient of 8 in front. We're going to do the same thing we just did on the last problem. We're going to square both sides, okay, and we're going to be left with 8 times 8, which is 64, times x minus 2 in parentheses equals x plus 14. Now it's important that you do leave these inside parentheses because our next step we need to distribute the 64. If you didn't have parentheses, you would have just had 64x minus 2, which would be incorrect. This next step we're going to end up with 64x and distribute the 64 to the 2. That's going to end up being 64 times 2 is 128. A negative 128. Right, next we're just going to go ahead and solve it like we would normally. We're going to subtract x to both sides. We'd end up with 63. I'm going to add 128 to both sides. Okay, 14 plus 128. We would end up with 142. Okay, divide that by 63. Okay, so that doesn't give us a pretty number. We would actually just stop right here. Okay, that simplifies out. We're left with x equals 142 divided by 63, and we'd substitute that back in to double check if we got the right answer. Okay, we're going to go ahead and move on. All right, now this one we're going to go ahead and subtract 3 to both sides because I want to isolate that radical before I do anything else. So this is going to be x minus 3 on the right side. Now that I've got the radical isolated, I'm going to go ahead and square both sides. Now we're going to end up with x minus 1 is our radicand, the number inside the radical, and x minus 3 squared. That broken apart, if you want to FOIL it out, okay, or use the box method, just multiply the binomial out. Okay, that's going to end up just being x squared minus 3x minus 3x plus 9. Okay, and if we combine like terms on the center, that's going to be x squared minus 6x plus 9. Now the next step that we're going to do is we're going to go ahead and move x minus 1 over because we want this side to be 0. So we're going to add 1 to the left from the left side to the right side. We're going to subtract x. All right, this becomes 0 equals x squared minus 7x plus 10. Now the next step is we're going to go ahead and look for our factors of 10 that add up to give us negative 7. Okay, so our factors, I noticed that we have a negative as our middle term. What we're going to do is we're going to have two negative numbers. Okay, so this is going to end up being 5 and 2. Okay, because that multiplies to give me positive 10, but adds up to give me a negative 7. Okay, so what we're going to do next is our binomials need to be set equal to 0 to solve for what x is. Okay, so 5 is going to equal x, and then x minus 2 equals 0. X is going to equal 2. We have two solutions for this. Okay, and so what we're going to have to do now is we're going to have to go back up and check our answers. I'm going to check it in red. Okay. All right, so I'm going to substitute the values back into the equation one at a time. So we're going to first test 5. So that's going to be the square root of 5 minus 1 plus 3 equals 5. 5 minus 1 is going to give us the square root of 4. Square root of 4 is just 2 plus 3. And that's 5 equals 5. So I know for a fact right now that x equals 5 is a solution. Just for kicks and giggles, let's check the next one. So we're going to start off with the square root of 2 minus 1 plus 3 equals 2. So 2 minus 1, that's only going to give us the square root of 1 plus 3 equals 2. So the square root of 1 plus 3 equals 2. Always simplify on one side until it's all the way done. So we end up with 4 equals 2. That does not equal. So x equals 2 is actually going to be our extraneous solution of the equation. So we are only going to have one solution, and that's going to be x equals 5. Okay, we're going to go ahead and skip this problem because that concludes our notes for right now. So we're going to stop here at 8. Okay, I hope you like this video. Please let me know how I can improve it. I hope you can rewind or slow things down or go back and see different parts of the video. And I hope it works out for you. Thank you.